Welcome back to Mr. Hassan's Maths channel. We are now on question 3 from the new specification for the 2020 IGCSE University of Cambridge paper. We're now on the paper 4, question 3, which is about functions, graphs of functions. Now here we have a function f of x, which is defined as 20 over x plus x, and they've mentioned that x cannot be 0, and you have to mention any exceptions to the function for it to be a function. And x cannot be 0 because if you put x in the denominator, you'll have something that's undefined. You cannot divide by 0, it's undefined. So that's the reason why they've mentioned x can't be 0. That's the reason why they've left the area between minus 1.6 and 1.6 here with this shaded thing where 0 would go. And that's why when they said draw the graph of the function, they've put two separate kind of parts to it because the 0 can't be included there. Okay, so that's the reason why they've done that. Then it says complete the table. Now in this table we can see there's 2 points missing, and we can kind of look at the pattern of the numbers and see, look, they're actually just duplicates on the negative side of each other. So we can kind of guess that the 5 is going to be a 9 and the 8 is going to be 10.5, and we can verify it, of course, by sticking that in our calculator. Or like 20 divided by 5, if you put x instead of 5 instead of x, 20 divided by 5 is 4, plus 5 is 9. So it seems like it's correct. And 20 divided by 8, you've got 20 over 8 plus 8. So 20 divided by 8 is going to be 5 over 4 plus, so 5 over, that's 5 over 2, sorry. 5 over 2 plus 8, that gives you 2.5 plus 8, which is 10.5, and that's correct. So we can see that those numbers are correct. You can stick in your calculator as well if you want, but those are correct, and you can see that there's a pattern that they follow. They're exactly the same numbers, but just negative. Okay, you can see that you got minus 1.6, minus 2, minus 5, minus 8, minus 10, and the x's exactly the same but positive, and minus 14.1, minus 12, minus 9, and so on, exactly the same here but positive. So you could see that that's a pattern there anyway. Now it says on the graph, on the grid, draw the graph of y equals f of x between these limits. So we're going to draw on the grid. So what I've done is I've taken a copy of that table and I put it down here so we don't have to keep going up and down. We can just move this up and down, and I can plot the points that I need. So you've got minus 10, minus 12. So we need to take this all the way down here. Minus 10, minus 12. Okay, so minus 10, minus 12. Now make sure the pencil is on the thinnest. Well, so when you take a pencil into the exam, make sure that it's really thin. And you use a pencil, not a pen. And it should be sharp. It could be one of those mechanical ones. It could be a normal one, but it must be sharpened. It must be very thin. Otherwise, it's not going to be so accurate. And we've got to mark minus 10 and minus 12. Minus 10 and minus 12 is exactly at this point here. Now, when you mark a point, what I don't want to see, or what the examiners don't want to see, is like big blobs like this. That's not what they want to see. And that's actually what some students do. All right, no, you want to make it like accurate so that when you put a line through it, it goes through an exact point, not like a big blob where you don't know where the point is. So what you're going to do is there's two ways of doing it. One is to make a point that's so, like there's a point there, but you can hardly see it. I mean, you probably wouldn't even notice it if you took your pen away and you looked away then. But if you circle that point, it's very clear that there's a point there. So you've got something very accurate to aim for when you're drawing the line. It's that dot inside. So it's very, it's important to do that. The other thing is you could, instead of doing a dot, you could do like a little cross like that. That's fine as well. But not like some thick kind of, nothing like that, or nothing like this, a big blob. Those are not going to give you accurate graphs. Okay, so now let's continue. So minus 8, minus 10.5. Minus 8, minus 10.5. Now we've got to work out what minus 10.5 is. Don't just put it, say, oh, that's minus 10 halfway down here. No, this is minus 10, that's minus 12. So here you can see that there's 5 divisions and 4 units. So each one must be 0.4. 0.4, 0.8. So that's 10.4, 10.8. That's 11.2, 11.6, and 12. Yeah, so it's going to be 0.4. So we need minus 10.5. So that's minus 10.4, and minus 10.5 is just below here. If I go further, it will be minus 10.8. So it's going to be closer to 10.5. So it's going to be just below this line, and we've got to go to minus 8. So just below this line, at minus 8, there we are. Then minus 5 and minus 9. So minus, not minus 6, minus 5. So of course that's exactly halfway between these two. So it's like, you know, halfway between these two lines. And minus 9 is halfway between minus 8 and minus 10. So again, it's going to be halfway between these lines. So it's going to be right at this point here in the middle of this square. Okay, that's minus 5 and minus 9. Then you got minus 2 and minus 12. That looks like it's a kind of easy one to do. Yes, minus 2, minus 12 exactly at this point here. And then minus 1.6 and minus 14.1. Okay, minus 1.6. Now this is minus 1.6. Each is 0.4. So it's going to be just along this line here. And minus 14.1, well, that's minus 14. And that's minus 14.4. So it's closer to minus 14. It's just below it. So something like that would be okay. And we've stopped there. So we can then draw this eventually. But let's go and just fill in this part first. Now you can see that these are all basically the same numbers, but just positive. So we got 1.6 and 14.1. So again, 1.6 is just before 2. It's like 1 square before 2. 14.1 is, that's the 2 there, yeah. 14.1 is just above here, just above 14. And there we have it. Then we got 2 and 12, which is a pretty easy one. 2 and 12 is right here. Then we got 5 and 9. So remember, 5 is halfway between 4 and 6. And 9 is halfway between 8 and 10. So it's going to be right in the square in the middle of both of those. And then you got 8 and 10.5. So 8 and 10.5, that's 8 and 10.5. Now remember, that's 10.4. So it's just above 10.4, which is going to be here. And then we got 10 and 12, which is back here again. So now we got to draw the line or the curve that goes through these, between these values. So now when you draw these curves, try to make your curve as accurate as possible. Try to make it one smooth line. It's not very easy with this pen here. And try to turn the page so your palm is on the inside of the curve. So you can see this is going to curve and it's going to come down something like this. All right. If you want to be even more accurate, what you could do is you could say, for example, let's find out what minus 3 is. If we put it into the formula, if you put minus 3 into the formula, you can find out more, you know, it can help you to draw it a bit more accurately if you want to. You don't need to, but it might help. So if you put, for example, minus 3, minus 1, not minus 3, minus, did I say minus 3 or minus 1? Where were we? Minus 3, yes, minus 3, because it's a bit unclear in that section there. So if you put minus 3 inside the formula, where are we? What was the formula again? It was 20 over x plus x. 20 over x plus x. So 20, I'll put over 3, and it'll be the same thing for minus 3, but negative. 20 over 3 plus 3. That gives you 9.67. 9.7, let's say. So when you've got minus 3, you're going to have minus 9.7. So you're going to have minus 3 and minus 9.7. So that's minus 8, minus 9, minus, that's minus 9.8 here. So it's going to be, this minus 9.6 is between, it's just over here. So you're going to have something, it's going to be something over here. So I'm just putting that point there just to guide me as to where my curve is going to go. All right, you don't have to do that. It's just a help to see how you're going to draw it in this section here. It sometimes does help. So then you're going to take one smooth stroke and you're going to go through these points with a smooth curve as best as you can. And you can stop there. You should stop there because it tells us to stop at minus 1.4. Okay, that wasn't too bad, was it? And now what I would do here is I would turn the page upside down and have my palm in here. If I try to do that here, it's going to cause everything to go out of place. So what I'm going to do is I'm just going to show you. I'm just going to do it as best as I can. So you just take a few trial runs. Remember, it was minus 3 and 9.8. So was it 9.8? 9.7. So this time it will be 3. 3 is going to be right here between these two, and 9.7. So it's going to be, that's 8, 9. It's just before 9.8. That's 9.6. Okay, so it's going to be somewhere over here. Okay, so that's just a guide. I'm not going to mark the point. I'm just putting a little dot there so I can see what's happening. So then you go through here, and there, and there, that was pretty good. Okay, not bad. All right, so there we have the graph drawn between these values. So basically what's going to happen here, this is going to get closer and closer to 0, will never reach it. And this will get closer and closer to 0, will never reach it. This is called an asymptote. X equals 0 is an asymptote, but we don't have to worry about that right now in this question. Now we can go on to part C. It says, using your graph, solve the equation fx equals 11. So basically, we're solving the equation fx equals 11. So remember, what we've drawn is y equals fx. So fx equals 11 is when this graph meets the line y equals 11. That's what it means. Fx equals 11. So you got to draw the line y equals 11, and you got to see the values of x where it meets. So you draw a line, and it should be a thin line, okay, across from 11, which is across from here. That's the line y equals 11. If you want to extend it through the whole graph, it's fine. Okay, so this is the line y equals 11. And you see where it hits the curve, and you should show these steps in your working, that you've drawn these lines showing where they meet. So there's one value there, and there's one value over here somewhere. So the accuracy here will depend on your graph and how well you've drawn it. So this actually, if we zoom in, which you can't really do, I guess you can if you just like look carefully at your page. But if I zoom in a little bit, I can see how well I've put these lines here. Okay, that's a bit better there, I think. And this looks like it's just right. Okay, good. So now we can see where these lines hit the axis. So remember, this is 2. This is 2.4. This is 2.8. This is 3.2. So this is 2.4. So I'd say 2.3 is okay. We can say this is 2.3. And this is 8.4, 8.8. That's 9.2. So this is like, I'd say it's around 9. That's 8.8. It's around 9, I'd say. 2.3 and 9.0. Okay, so I'll write those as my answers. Let's go back out to the normal view. So 2.4 and 9.0. Did I say 2.4? What did I say? I can't remember. Oh, 2.3, sorry. 2.3 and 9.0 are the answers according to the graph that I've drawn. Okay, so you might not, they will probably give you a range of accuracy for this question. And as long as you're within that range, it's fine, because it depends on how well you drew your graph as well. Then it says k is a prime number and fx equals k has no solutions. Find the possible values of k. Okay, find the possible values of k. So now, k is a prime number and fx equals k has no solutions. So fx equals k is basically a line which is horizontal. Okay, let me draw it with a solid. Okay, it's a horizontal line, fx equals k. All right, fx equals, so this is, for example, fx equals 8. What we just used was fx equals 11 before. This is fx equals 0. So you can see there's no solutions when it never touches the curve. And it never touches the curve everywhere above this point and everywhere below that point. It never touches the curve. So we got to think of all the prime numbers from this down to here. Okay, so the prime numbers from here down to there. So we got to include all of the prime numbers between these two values. So we have to find all the prime numbers between these two values for which it never touches the curve. Okay, all these places there's no solutions. Now the question that we have to ask ourselves, these are negative numbers. Is -2 and -3 and -5 and -9, no, -9, no, -9 is, that's actually out. Anyway, negative numbers are not prime numbers. Prime numbers are defined as numbers which are greater than 0, which are positive. Okay, a prime number is a positive number which has exactly 2 factors, no more and no less. So 1 is not a prime number because it only has 1 factor. 2 is a prime number because the only factors are 2 and 1. 3 is a prime number because its factors are 3 and 1. 4 is not a prime number. 5 is a prime number. 6 isn't a prime number. 7 is a prime number. 8 isn't, and 9, well, 9 is not in our range, because if we even look at our graph, this goes, 9 is actually one of the values there, okay? And so this goes below 9 anyway. So we can see that the prime numbers here are going to be 7 and 5 and 3. 1 is not a prime, and 2. 2, 3, 5, and 7. 1 is not a prime number, and negative numbers are not included as prime numbers. Okay, there's a big discussion why, but you don't need to go into that details for now. Basically, a prime number is defined as a number that is a positive number which has exactly 2 factors, which are basically 1 in itself. Has no more than 2 factors. So 1 has a factor, has only 1 factor, just 1. But 2, 3, 5, 7, oops. Anyway, 9 wouldn't even be counted as a prime number. I don't know why I even said that, because 9 is not a prime number anyway, because 9 times 9 can be expressed as 9 times 1 and 3 times 3. So 2, 3, 5, and 7 are the only prime numbers in this range. Are the only positive numbers, okay, which have exactly 2 factors, no more, no less. So the answer is 2, 3, 5, and 7. 2, 3, 5, and 7. 2, 3, 5, and 7. So there's the answer to part D. Then it says the gradient of the graph y equals f of x at the point 2, 12 is minus 4. Write down, means you don't have to calculate, you don't have to do any drawings or anything. Write down the coordinates of the other point of the graph y equals f of x, where the gradient is minus 4. Okay, so now we can see that there's some sort of symmetry to this curve, to this graph. I'm going to just zoom out so we can see the whole thing in a bit more detail together. Yeah, so we can see the whole graph there. So it's saying a minus 4. At 4, the gradient is, here the gradient has a particular value of, sorry, 1 second, let me see what it said. Is the gradient of the graph at the point 212, sorry, 212. The gradient of the graph at 212 is minus 4. So the gradient of the graph at 212, so 2 and 12 is minus 4. So the gradient here is minus 4, as you can see. So I'm going to draw like a tangent to the curve. That's like a tangent to the curve at that point. It's roughly done. Okay, so there's a tangent to the curve at that point. It kind of touches the curve at that point without passing through it. And you got to find another place on the curve which has exactly the same gradient. So we can see it's going to be minus 2 and minus 12 because of the symmetry. So without even looking at the graph, we could even see that. But looking at the graph, you can see, I'll just show it to you, that at 2 and negative 2 and negative 12, it also has the same gradient. You can see that the tangent also is the same, just touches the curve at that point and that point. And it's because it's symmetrical. Okay, it has this kind of rotational symmetry here. So you can see that the answer is negative 2 and negative 12. And that's why it says write down. You can just look at it and see. You don't have to write down any calculations for that part of the question. Okay, so that's negative 2 and negative 12 is the answer here. Negative 2, negative 12, only worth 1 mark, no calculation needed. Then F part 1 says the equation f of x squared, f of x equals x squared, can be written as x squared plus bx squared plus q equals 0. Show that p equals minus 1 and q equals minus 20. So if we remember, f of x was a function, was it 20 over x plus x? I'm just going to make sure in case I wrote it down wrong. Yeah, 20 over x plus x. Okay, that was a function. So they're saying that the equation f of x equals x squared. So that means you've got to take this and make it equal to x squared. So you have 20 over x plus x equals x squared. Now you want to show that this equation looks like this. So basically we've got to get rid of the fraction from this equation. So we multiply by the denominator, which is x. So when you multiply this term by x, it becomes 20. This term by x, it becomes x squared. And this term by x, it becomes x cubed. Equals, sorry, there's an equals there, not a plus. Equals x cubed. And if we bring everything to one side, leave 0 on this side, you've got x cubed minus x squared minus 20. So that means x squared minus x cubed, sorry, minus x squared minus 20 is equal to 0. Let me just write that cubed a bit more as a superscript here. Okay, so what's going on here? x cubed minus x squared minus 20 is equal to 0. So we've shown that p is equal to minus 1, because that's px squared minus 1x squared, and q is equal to minus 20. So we've shown that by just rearranging this formula. So f of x equals x squared, you take f of x and make it equal to x squared, and you rearrange it so it looks like this. So you got rid of the fraction, multiplied everything by x, and then rearranged everything on one side. Then it said on the grid opposite, draw the graph of y equals x squared for minus x between minus 4 and 4, and using your graph, solve the equation x cubed minus x squared minus 20 equals 0. So we got to draw the graph of y equals x squared between minus 4 and 4. So that's a quadratic graph. Okay, you'll only need the top part of this. So let me just get rid of some of these things here. I'll get rid of this line. I'll get rid of this line. And I'll get rid of this line. Okay, now, really, you know, I think for you guys, just leave it there. Leave those lines there as much as best as you can, because that's your working. That's your working. When the examiner looks at your work, you'll see that that's your working. All right, so now, so I'll leave it there as well. So y equals x squared between minus 4 and 4. So y equals x squared when x is equal to minus 4, y is equal to 16. So it's going to go through this point here. When x is equal to minus 3, it's going to go through 9. So it's going to be, that's 8, that's 10, that's 9, and minus 3 is halfway between these two. It's going to be right over there, that's 9. Same level as that, that's right. And then you got when y equals minus 2, when x equals minus 2, y equals 4, x equals 0, y equals 0, x equals 2, y equals 4, x equals 3, y equals 9. It's going to be right here. And when x equals 4, y equals 16. Okay, so we've got to draw this curve like that. Let me just get rid of these numbers because it looks a bit confusing here. We finished with the prime numbers. Okay, so just to make it a bit less clogged up. So now we got to draw this curve, okay, using a thin pencil. Okay, now this is going to be a bit difficult for me to do because it's like really narrow, and you know, I've just got this electronic kind of pen. You need to turn the page over when you do it and just be as neat as possible. Let's see how well I can do this. This is a bit more tricky than the other one. Let's go. It's not as good, but it's all right. It's all right for now. And then you get to there, and then it turns up, and it goes up, up. I'm kind of missing it a little bit. Up now. That's not so good. That's not so good. It should be a bit more smooth than that, this part here. So I'm not happy with that. I don't know. It's going to take up some time in the video, but I'm not too happy with that one. So you see, you have done it by pen. You can just you can just rub it out and start again. This side is a bit better, but it should really go through that dot. Okay, so it's a bit difficult to do with this pen. But anyway. So here we go again. Bismillah. It's still not as good as I want it to be. All right, I'll just have to give up. It's not bad. Anyway, so we can see that there's one place where they intersect, which is here. And that would be the solution to where x squared is equal to this graph. Let me just use a thinner and dotted line. So where they intersect, which is about here, is going to be, okay, the place or the solution to that equation. And you can see that's like at about 3.6, because remember these are 0.4. 3.6, that's about 3.6. So that's the solution, because it says using your graphs, solve the equation x squared minus x cubed minus x squared minus 20 equals 0. That was the equation that we made from equating our graph, our function, to x squared. So the solutions of this equation will be the solutions of where these two intersect, because that's where they're both equal to each other. So that equation led to this equation, and this equation, the solutions to it will be where they intersect. So we just write down the point where they intersect, which we said was, what did we say? We said it was, let me just make sure, with 3 point something. It was 3.6. 3.6. Okay, so there we have 3.6. Okay, and then I think there's one more part to this question. And it says the diagram is a sketch of the graph of y equals x cubed minus x squared minus 20. P is the point n0. Write down the values of n. So remember, we just solved the equation x cubed minus x squared minus 20 equals 0. And we said that the value of this, okay, the value of the point where it equals 0, this is where this graph equals 0. This is the graph of what the function you get when you rearrange that equation, the original equation. So the solutions to where this equals 0 is going to be exactly what we just wrote down just now, which was 3.6. So that's why it says write down. It's not like a question you have to calculate anything. It's only worth 1 mark. And there we have the answer to this question. So I hope you understand why, because this equation, we formed it from equating f of x equals x over 20 plus x, and f of x equals x squared. So when we made them equal to each other, x over 20 plus x equals x squared, and we rearranged it, we ended up with the equation exactly what we got here, x cubed minus x squared minus 20 equals 0. And where does this equal 0? Where this, and what we've drawn here is a sketch of this. That's what we've been given. And where does it equal 0? At the point P. The point P is the solution to this equation, where this equals 0. So it's also the solution to this equation, because this equation comes from that equation, and the solution to this equation is where they intersect. So that's where we got it from in this graph. Where they intersected was that point where x equals 3.6. So there's the answer. I hope that was clear and understandable. And if you would like to watch the next or other videos from the paper 4, from the same paper, you can click on the playlist that shows up on the top of the screen here on the right. Below it will be a playlist for the topic of graphs of functions, which this question is from. And if you'd like to subscribe to my channel, you can click on the icon that will appear over here. Thank you for watching, and I'll see you in the next video.